Hi, welcome to the promises section in our ES6 portion of the React Bootcamp training. All right, let's take a look at our promise CodePen. So promises primarily we're primarily going to be talking about asynchronous computation or asynchronous behavior. So before we get in too much into promises, let's talk about what is asynchronous behavior. Asynchronous behavior is behavior that runs, you can think of it as behind the scenes. It's not going to run in the same linearly within the same process. So things that initiate asynchronous behavior are usually like user interaction, maybe waiting for user input, or network requests. Those are two common things. And the way that these have been accommodated in the past has primarily been through the callback method, where you would pass a function into another function. When that asynchronous computation is done, that callback would be called. So promises are a new way of dealing with asynchronous computation. So a promise, at its core, the promise represents a value. And that value could be available now or in the future or never. So this is represented by three different states the promise could have. The promise can be resolved, pending, or rejected. Meaning resolved, you have the value. Pending, you don't have it yet and you may not. Rejected, you're not going to have that value. So we're going to be in this section authoring promises, and typically we're going to be interacting with promises, but I think it's important to know how promises are working behind the scenes. So we're going to learn about authoring promises. So a function is passed to the promise, and that function accepts two parameters, resolve and reject. Resolve is called when a successful condition is met. Reject is called when an error or an unsuccessful condition is met. So in fact, I've said that these are called. What can we assume then about the nature of resolve and reject? Resolve and reject are functions which are called, right? So promise is a function which accepts a function, and that function accepts two parameters, resolve and reject, which are functions. So this is fun. Functional. All right, so here's a look at a promise. So when we call resolve, that's going to trigger then, the first then, to be called. And when reject is called, that'll trigger reject. So let's look at this function. So we have a const p equals a new promise, which accepts a function. Here's the body of that function, right? And that function itself accepts resolve and reject. So we're going to have some condition, which is a function that returns a Boolean. And this could be like a network request or some asynchronous action, right? So if that condition is true, we'll call resolve, and we're going to pass resolve data. It's important. Whatever data we've received from our communication, we want to pass that into resolve. Or if we just want to return, success or true, we can pass that into resolve. And if that's not true, we'll pass a string error, and you can pass an actual error message, or you can reject the data. And when reject is called, if this condition is not true, right, this would trigger a catch. So on our p object that we've declared here, we have p.then, which takes a function, and that function has the response. And what we're going to do is we're going to log out that response. So this res response here, this is the data that we're passing into resolve. If there's an error, or if our condition's not true, it's going to call catch, which has the same inner function body here, right? We're taking data and then just logging that data. So this response is whatever we pass in here to reject. Something useful about then and catch is that they return new promises themselves, right? So if you don't implicitly or explicitly return a value, then it will still return just a promise object that you can chain. And so the benefit then is you can have multiple thens. You can do an action, then do another action, then do another action, right? You can chain these together. So if you have a series of chained thens, any catch statements can come in the middle of these thens and catch errors or catch rejected promises above them. So then catch anything up here, and you could have more thens after that. So let's take a look at a kind of pseudocode, but as an example of how you could use multiple thens together. So say we had some function or some part of our web application we want to sign up new users, and that sign up process has several steps. We want to display a hooray message. We want to queue a welcome email. We want to queue up a handwritten postcard, and then we want to handle errors. Right, so we have these functions here. These are our functions that are going to be called. We're going to sign up a new user, which is a promise. And after that sign up new user resolves, right, or rejects, this is what we're going to do. We're going to sign up a new user, then display the hooray message, then queue up a welcome email, catch, and then pass in our error handler function. So anything from these first two, right, if we want to display the message or get the welcome email, any errors or unsuccessful conditions from those will be caught by the first catch here. After those are done, we want to send a handwritten postcard. That's definitely going to be asynchronous, and we want to catch any error after that happens. So in this model, our welcome email could fail, but our handwritten postcard would still be called and could still be successful. So this is a powerful pattern because it allows us to deal with many different asynchronous possibilities, right? We don't know how long the welcome email will take to send. We don't know how long the postcard is going to take to send. And yet we can work with these functions as if they were synchronous, right? Because these are all going to happen in order. We're saying, do this thing, it's our promise, sign up the new user, then display a welcome message, then send an email, then write a postcard, right? So we're going to do these in order as they occur, but each individual action itself is asynchronous. So this whole block of thens and catches is going to run asynchronously. Anything immediately after this sign up new user call would be executed. The execution would continue. Promise.all. So here's another, we have several static methods on promises, right? You have promise.reject, promise.resolve. Another static method on the promise object is promise.all. Promise.all returns a promise that resolves when all of the promises in the iterable argument, so an iterable argument would be something like an array, something you could iterate over, right? In an iterable argument have resolved or rejected with the reason of the first pass promise that reject, right? So it's going to reject with the first reason that it was rejected, or return all of the values. So in this case, we have three promises: promise 1, promise 2, promise 3, and each of these have different internal method bodies, right? So the first one is going to resolve after 1 second, and the second one is going to resolve after 2 seconds, and the third one is going to resolve after 3 seconds. Right, and the value that would be resolved is the string 1, the number 2, or the string 3. So we call promise.all, pass it an array of those promises, and then values, what we get back, is an array which contains each of the resolved data. So this would be useful for situations perhaps like making network requests when your application is starting. If you need to make, check the user's logged in, get data for the header and footer, get the page content. If these things all need to happen at once, then you can put them in an array and pass that array to promise.all. And when each of those happens, then it would be able to, or it would give you back that data. So just to iterate or reiterate real quickly, it's uncommon, I think, that we're actually writing promises themselves. It probably follows the 80-20 rule, right? 20% of the time we're going to be writing and authoring a promise, where 80% of the time we're actually just going to be interacting with promises that have been returned to us like from a network request library or some user input library that we're using with. So that's very common, interacting with them, with promises. So we have a couple activities. We'll go through both of these. The first activity we're going to work on In the JavaScript tab, there's a cheating dice promise, which is provided, and that can resolve or reject based on the cheatiness threshold. Write a then statement, which will log the dice roll value, and a catch, which will be triggered if a bad roll happens. Right. So in the JavaScript tab, there's this object, and this object accepts a value, and that value is used later on in the promise. Right. And so if you look at the kind of what this looks like, this is a variable dice, and we're assigning that a function, and that function accepts a value, which then returns this promise. Right. So I'll go ahead and pause the video now, and work on this activity. Okay, let's go ahead and work on activity 1. So I'm going to open up the console. So we want to interact with this dice object, right? We can use our function Spidey Sense and see that we need to, dice is a function, we need to pass a value. So a dice of 3. And now let's look at how this value is used. So we're going to, in the function, or in the promise, excuse me, we're going to have a timeout for 1 second. And we're going to have a roll value, which is a random number between 1 and 6. So if the roll value is higher than our cheatiness threshold, then that's a successful roll. If it's not, if it's lower or equal to, right, we're going to reject that value as not being high enough. So we want to have this dice here, and this is a function which returns a promise. So we'd like to hold our promise in some variable. So say const my dice equals a dice of 3. Then we can put on our then or catch statements. Say my dice dot then, and this is going to return. So this is a function, right? So it's going to have a result, which is our return value, and what we want to do is log out whatever that was. So let's add some string template literal here. We'll say the result was great. Okay. And then if it was not adequate, we'll write a catch statement. And we'll just log out the value. All right, so our first roll, 4 was high enough. It passed our threshold that we passed in, and so we called resolve, and that triggered the first then to happen, and it was great. When the function was called again, because of the auto running nature of CodePen, right, as I continue to type, it ran the function again. The second time, 2 was the value that was generated by the random call, and 2 was not high enough. All right, let's go ahead and take a look at the second activity. All right, the activity plus. So we're going to promisify the callback-based function set timeout to create an async sleep function, which could be used like this: async sleep of 3,000 milliseconds, then do some behavior. So this is one use for promises. Like I mentioned at the beginning of this video, many built-in functions are based on callbacks, like user input, right, is callback based, set timeout, set interval, those are callback based functions. But it's possible to take any callback based function and wrap that in a promise, and so we're going to promisify that function in order to use it as if it was a promise, right? Because it will be a promise. So we're going to take a callback based function set timeout and create a promise version of set timeout. So let's go ahead and do that now down here. I'm going to first comment out our dice code. Okay, so if we want to create a promise, let's first create an object, const async sleep, and that is going to equal a new promise. And what do promises accept? They accept a function, and that function accepts two methods, resolve and reject, two parameters. So what we want to do now is we want to actually make this a function which we can also pass into the amount of time we want to sleep for, right? So let's modify this a little bit. We want to sleep for, we'll say milliseconds. So async sleep itself is not a promise, but now it's a function which returns a promise. It's going to be based on number of milliseconds. Let's say window.set timeout. And what we're going to call is resolve. And we're going to call that after milliseconds. So in this case, our promise this promise isn't going to reject. If we wanted to cancel the timeout, right, or cancel the async sleep, I guess we could write some code that would use reject to cancel it. But we won't do that now. So if we want to sleep for 5 seconds, or let's do something shorter for the example, we'll just do 1 second. Async sleep of 1 second. Then console All right, I didn't get the console logged as I would expect, so let's go ahead and see what happened. Set timeout is not a function. I wonder why. Let's go ahead and change this to set timeout. There we go. So so we have this promise-based timeout now called async sleep, and it waited for 1 second, and when it was finished, then we did this operation. So we could set this. We'll set this for 3 seconds. We'll say we'll change the string here to world, and we'll wait for 3 seconds. There we go. So this is a common pattern you could use. The takeaway here is not creating async sleep functions. Just want to point that out. Right? The takeaway is in the pattern. The pattern of being able to take a callback-based function and wrap that with a promise and be able now to interact with this function in a promise environment. It's a really powerful pattern. Something useful to look for opportunities if you have opportunities to do that. All right, the next video in our series is fetch.